You have a function, there will usually be several properties that will be important. Okay, so a function is said to be, so let's call this function f from D to C, okay, is said to be one-to-one. Okay, or injective. Sometimes instead of saying function from D to C, they say D into C to emphasize this. So these three conditions all mean the same thing, and they mean that if anytime f of x equals f of y for some x and y in the codomain, the domain. So anytime the output of two inputs is the same, then the inputs are also the same. So basically, if you have two different inputs, they'll go to two different outputs. That's what one-to-one is saying. See, one input for one output, one-to-one. There's no two inputs going to the same output. That's 2-to-1 or more to one, okay? So injective, the meaning of that, this particular way of saying it might only become clearer to you as you do more examples with functions. Okay, it is, and then there's another notation actually. So sometimes people write D this with a hook arrow to emphasize maybe the injecting of D into C. Okay, it is surjective onto, so onto as opposed to into, D onto C. If for every element of the codomain there exists an element x in the domain such that f of x equals y. So this is saying every element of the codomain is actually an output of the function. So there is some input that reaches every element of the codomain. Okay. It is bijective if it's both injective and surjective. And let's just take an example right now. Okay, an example. So let's take an example. C equals, D the domain equals 0 and 1, and the codomain C equals just one thing, let's say it's 5. Okay, and define our rule to be 0 goes to 5. Notice how 0 has to go to 5. And 1 has to go to 5. There's only one thing it could go to actually, because everything here has to go to something here, and there's only one thing here, so it has to go to 5. And because everything here, 0 and 1, both went to something, then it's enough to define a function. Okay, so this is an example of a function. It is not injective, so it does not satisfy the first condition because there's two inputs that both go to the same output. Okay, so but it is surjective because there's only one element in the codomain, and surjective says for every element in the codomain there exists an input that outputs that. So 5 is the only thing, and there's certainly inputs that output 5. So it's surjective, but it's not injective, and that's an example. Some quick extra jargon. We have the image of a function. So of a function, let's say it's going from D to C. The image of f of this function, or range. Sometimes it's denoted f of D, is exactly the set of all y such that y equals f of x for some x in D. So it's exactly the set of outputs. And to relate this a little bit to our earlier thing is that the function is surjective or onto exactly when its image is all of C. Okay, so the image is always a subset of C, and when it's all of C, the function is surjective. Okay, so the preimage so we're talking about the preimage, not of the function. We're actually talking about the preimage of a subset of the codomain. So the preimage of a set X contained in the codomain is the set of all X in the domain, Y in the domain, such that f of y is in big X. Okay, so the preimage of X is all the elements in the domain that have an output in this subset. Another notation for this is f inverse of X, or maybe f inverse of X without the brackets sometimes.